Hello, in this video I will ramble about resonance hybrids versus tautomers and certain ions and certain functional groups that I find interesting. Let me start with the resonance hybrids versus tautomers because this is the more difficult task. I will exemplify with the cyanate ion, which can be a resonance hybrid. What we have here means that this is a single species with the molecular properties given by the average of these two resonance forms, or you can call them resonance structures. It doesn't have to be in a proportion of 50-50. Maybe the properties like the bond length or the bond angles are best described by the second structure. And the difference with tautomers, I will do a very interesting thing. I will hold control to make a copy. You see, control while dragging makes a copy, but I will also hold shift. And what holding shift does is that it only allows you to move on the vertical or on the horizontal. And now I will give an example of tautomers. In cyanic acid, I added a hydrogen, and isocyanic acid. But we would have to use different arrows for this. These are the arrows that mean that these two species, so in this situation they are different species, readily interconvert if you have them in solution. So for example, if you had this in a beaker cyanate, you have a single species with properties as the average of these two structures. If you would have this in a solution, the proton would keep moving from one side to the other, and you would actually have two different chemical species that would interconvert. I'm trying to arrange this nicely because I will put the document in the video description. But it's not easy. Okay. Well, I have tried. Now to move on, actually maybe I should also tell you, let me give one more example of a resonance hybrid. Let's say I want one with three forms, so let's go with carbonate. So this is carbonate. I would prefer to call it carbonate ion. This time the charge would be 2 minus. In this case it was 1 minus. It's a resonance hybrid with 3 resonance forms. By the way, tautomerization usually happens by the relocation of a proton. So in this case, the protium moved from the oxygen to the nitrogen. You can also, let me show an interesting thing regarding resonance hybrids. You can also write them, represent them like this. Now, I wish I knew how to add the text directly here. So, because I want to add the charge here in this case. I'm sure there is a way. Sadly, ChemDraw doesn't have a double bond, triple bond with a dash. So, for example, if I wanted to make cyanic acid, I would have to do it like this. Let me add the oxygen, the carbon, not cyanic acid, the cyanate. Okay, so between the oxygen and the carbon, the bond can be double or triple. Okay, so ChemDraw doesn't have this kind of bond. And between carbon and nitrogen, single or double bond. And the negative charge is split between the oxygen and the nitrogen atoms. So let me do a delta. This would be another way of representing a resonance hybrid. Okay, so I also want to discuss a bit other ions and functional groups. More specifically, thiocyanate. Thio means that in cyanate, thio means that the oxygen is replaced with sulfur. So in this case, let me just copy this and I will change it. This time I didn't hold control anymore, so I will make a copy. I will just move this one. So this would be thiocyanate ion. And maybe also do cyanide. And I will talk about how all these three can act as functional groups as well. By the way, I'm learning from a free book from OpenStax called Chemistry Atoms First, Second Edition. I'm also using Wikipedia and to be honest, a lot of other resources, including the help of these programs. Okay, so how would the thiocyanate and cyanide look as functional groups? Well, let me start with the benzene ring, and I will add let me start with isocyanate. Iso means that the nitrogen will be first. And this is probably more likely, right? So let's see. Yes, isocyanatobenzene. And this would be the isocyanate functional group. Functional group. I will use FG from now on. Now let me just copy this. And if the oxygen is first, in this case, this would be the cyanate ester functional group, where ester means that the hydrogen from hydroxyl has been replaced by another ligand, in this case cyanide. Cyanate ester functional group. Okay. Now, these two would be linkage isomers. And cyanate and the isocyanate functional group is an ambidentate ligand, meaning that it can connect to the main structure with both ends. You can say cyanate ester functional group is or any of them. These are not tautomers though, because this one they will not most likely rapidly interconvert in solution in this way. Okay. I will do the same for thiocyanate by just with the copy and paste. If we simply have sulfur here, this is isothiocyanatobenzene, and this would be the isothiocyanate functional group. And this would be thiocyanate functional group. And in this case, the thiocyanate functional group is an ambidentate ligand. How about cyanide? It can also be a functional group. It's called nitrile usually. So this would be benzonitrile. It can be called the nitrile functional group as well, but usually in organic chemistry, not in organic chemistry. And let me show something interesting about the isonitrile functional group. I find it really interesting. So if we have isonitrile, the isonitrile functional group is actually a resonance structure in itself. So this is how we would be better to represent this. Now, I believe it's wrong to change the naming here. So hopefully, if I'm wrong with this, that this is a resonance hybrid, someone will correct me in the comment section. By the way, these ions can also act as bridging ligands. So let me exemplify with this, actually just with this, so less text. Bridging ligand means that they connect to bigger structures, and actually most organic compounds can act as bridging ligands, but the term is usually used for small molecules. So if we had it like this would be the nitrile functional group acting as a bridging ligand. Let's call it cyanide. Okay, I will put this document in the description, and hopefully you've learned something today. Bye bye.